A sequence is a list of numbers. There are different types of sequences. There is a finite sequence, and a finite sequence has an end term. That is, that it does end. An example of a finite sequence would be something like 2, 4, 6, 8, 10. An infinite sequence, on the other hand, is a sequence that has no end. An example of this one would be 2, 4, 6, 8, 10, and this pattern carries on. Sequences are made of individual terms, so a term is each number within a sequence. Today we're going to be looking at arithmetic sequences, and an arithmetic sequence is a sequence where the difference between two consecutive terms is constant. This difference is called the common difference, and is D. So here we have a sequence 2, 5, 8, ... to 23. This is T1, T2, so term 1, term 2, term 3. This is considered the nth term. We don't know what value it is. Another name for T1 is A. D is found by subtracting any two consecutive terms. So if you look at this one, 5 minus 2 is 3. D could have been T3 minus T2, which is 8 minus 5 equals 3. Okay, the formula for arithmetic sequences is T to the n equals A plus n minus 1 times D. We've already established that T to the n is the value of the nth term. This is quite often also the last term. A is the first term. You'll sometimes see it as T1. N is the number of terms in the sequence. D is the common difference. Okay. So looking at question number 1, identify the common difference of 7, 12, 17, 22. We know that D is just the subtraction of any two consecutive terms, so this could be 12 minus 7, which is 5. Now for letter B, negative 4, negative 7, negative 10, negative 13, I'd like you guys to try that one. So pause it at this point and calculate D. D is T3 minus T2, and again, it doesn't matter what terms they are as long as they're consecutive. So this is negative 10 minus negative 7, negative 10 plus 7, which is negative 3. Okay, determining the first term A. There's a number of different ways to do this one. If you've been given two consecutive terms like we have here, we know that this is T1, this is T2, this is T3, T4, T5. So we can calculate D. We know D is 23 minus 19, and this is 4. And then we can just work backwards because we only have to go back 3 terms. So to go this direction, we are just going to subtract the common difference. So this would be 15 subtracting 4, this would be 11 subtracting 4, this is 7. So A is 7. Sometimes you're not able to do this. In question B, you're looking here, we have to calculate what the common difference is. The easiest way for me to calculate the common difference is, again, to set this up. We know to go from one term to the next, we add d, right? The common difference. So we just keep adding d's till we link the two known terms together. This sets up an algebraic equation. We have 4 plus d plus d plus d plus d, which is 4d, and this is going to equal the last term, 10. From here, it's just our basic algebra. 4d is going to be 6, divide both sides by 4, we get 6 over 4, or 3/2. At this point, because we have a t2, I would just say we're going to subtract d, so 4 minus 3/2, and that is 8 minus 2 minus 3/2, so 5/2, or 2.5. Okay, now we're going to start to use the formula Tn equals a plus n minus 1 times d. So Tn equals a plus n minus 1 times d. You could do this the long way. You can figure out what the common difference is, and then you can just write out all 40 terms, because we are looking for T40. However, using the formula will save you a lot of time. What I like to do is just label out my variables and substitute what we know. N is 40. A is the first term, which is 15. D is found by subtracting 2 terms. So D is -4. We are looking for the 40th term, which is Tn, the last term. So substituting in, T40 is equal to 15 plus 40 minus 1 times -4, which is 15 plus 39 times -4. This works out to be -141. So T to the 40 is -141. What that means is that if you carry this sequence on here to the 40th term, it is going to have the value of -141. Okay, similar type of question. This is 170 is which term? So we are looking for the value of the term number. So again, Tn equals a plus n minus 1 times d. Tn a n d. Fill in what we know. Start with the easy one. A is -4, the first term. D is 6, and you can calculate that. 8 minus 2 is 6. This is the part that people struggle with, the difference between Tn and n. This 170 is the value of the last term. Therefore, Tn is 170, and we need to calculate what term number is 170. So this is what we're looking for, which is n. Substitute everything in. So 170 equals -4 plus n minus 1 times 6. I'm just going to rewrite this as -4 plus 6 minus 1. Add 4 to both sides. So this is now just into our basic algebra. So we're going to add 4. We get 174 is 6n minus 6. Add 6 to both sides. We we get 180 equals 6n divided by 6 divided by 6. N is 30. So 170 is the 30th term. A good check for n is n must be a whole number. It cannot be any part of a term, so it must be numbers like 0, 1, 2, 3, 4. Okay, moving on. This is just an algebraic version of one of the previous questions. What we're looking at here is we have these three terms. So this is T1, this is T2, this is T3. Just give ourselves a little bit more space. So we know that from our notes that D equals T2 minus T1, and we know that D equals T3 minus T2. What we can take from this is that T3 minus T2 is going to equal T2 minus T1, because those are both equal to D. So substituting this in, we have 10x plus 6, I'm just going to put it in brackets because we are subtracting, minus 7x minus 4. This is going to equal 7x minus 4 minus 5x plus 2. This is, this is T3, T2, T2, T1. So now we're just going to solve for x. Once we have the value of x, then we can substitute into the original T1, T2, T3, and that will give us the values of the first three terms. So 10x plus 6 minus 7x plus 4 equals 7x minus 4 minus 5x minus 2. Collecting like terms, 3x plus 10 is 2x minus 6. Subtract 2x to both sides, subtract 10 to both sides, and that gives us x equals negative 16. And all that's left to do is substitute into T1, which was 5x plus 2, so this is 5 times negative 16 plus 2, and this works out to be negative 78. And then just repeat for the other two terms. Oops. So T2 is going to be negative 112, T3 and this is negative 154. So there's the first three terms of that sequence. Okay. So again, in this one we're looking for the value of a, and we know that arithmetic sequence has T4, so the fourth term is 23, and the 11th term is 65. So you could write this out like a previous question. So you could solve it like question 2a or 2b. However, because there's quite a bit of difference between the two term values, 4 and 11, I'm going to show you an alternate method that will work. We know that Tn equals a plus n minus 1 times d. We know that in T4 we would have the fourth term being, actually let's start that one over. Let's say, I'll label it this way. We know for T4 that the fourth term is 23. We don't know what the first term is. We know that n corresponds to 4. So this is 4 minus 1, and we do not know the value of d. We can do the same thing with t11, and we know the value of t11 is 65, and that's equal to a, which again we don't know. N is 11, so 11 minus 1 times d. Simplifying these out, we get 23 equals a plus 3d, and 65 equals a plus 10d. We can now go back into our solving systems work through elimination. We can subtract both of these, and that is going to give us 23 minus 65, which is negative 42. A minus a is 0. 3d minus 10d is negative 7d. Divide by negative 7. And this gives us d equal to 6. Knowing that we have d equals 6, we can just substitute into either one of these two equations and solve for a. So I'm going to put it into the T4 equation. So we know 23 equals a plus 3 times d, which we have just calculated as 6. So 23 equals a plus 18. A is 5. Okay, our last example for today is a display of cereal boxes. Has 16 rows. In the third row from the bottom, and 6 boxes in the 8th row from the bottom, and 2 boxes in the top row. How many boxes are in the bottom row? So ideally what you would like to do is to draw a quick little sketch of this. So we know that 16 boxes are in the third row from the bottom. So this is going to be our bottom row. This is going to have 16. And 6 boxes are in the 8th row. So this is T1, T2, T3, T4, T5, T6, T7, T8, and this is 8. And 2 boxes in the top row. So what we have here is again a question very similar to one that we did, so you can solve this one using systems, or you can solve it using just simple algebra techniques. Oops, sorry. That was 6. So we know to go from term to term to term, you can just add d's. So this equation is going to be 16 plus 1, 2, 3, 4, 5 d's, and that's going to equal 6. Subtracting 16 to both sides, you get negative 10, so d is negative 2. We know to go from this way then is minus d, so that is going to be 16 minus negative 2 minus negative 2, which is 16 plus 2 plus 2, or 20. So there are 20 boxes in the bottom row. Okay, general term. The general term is just an equation that will solve for anything in one particular sequence. So every sequence will have its own specific general term. Writing the general term in this one, we know Tn equals a plus n minus 1 times d. We can substitute what we know, Tn, a, n, d. So general term, a and n, remain variables, and you just substitute a and d into the values. So we know d is -2, and a we calculated as 20. So the general term is Tn equals 20 plus n minus 1 times -2. We can rewrite that. Oops. It's minus 2 n minus 1 times d. -2n plus 2. So this would simplify to 22 minus 2n. So our general term is Tn equals 22 minus 2n. Okay, using this will allow us to calculate any value of n or Tn for this particular sequence. So we know, reading the question, that there are 2 boxes in the top row. So that is the value of Tn. We want to calculate how many rows there are. So we can use this formula that is specific to this sequence and solve for n, where Tn is 2. So what do we have? Subtract 22 to both sides. So -20 equals -2n. Divide by -2, divide by -2, n is 10. So there are 10 rows in the display. And that is the end of 8.1 Arithmetic Sequences.